Hello, my dear students and the rest of the learners. Welcome to part 28 of a 7-part series of tutorials in computer structured programming in C and Pascal. This is section 7 of 13 in the topic data structures. My name is JM, or you can simply call me EMELISWAP. In this tutorial, I'm going to look at the data structure that we call records or structs in C programming language. I'm going to look at the definition of records or structs, the declaration of records or structs, accessing structure members, initializing records or structs, inputting data to and outputting data from a record or a struct, array of records, or what we call arrays of instances. And we are also going to look at passing of structs to functions. Let's commence by looking at records, or what we call struct data structure. This is a data structure used to store elements of different data types using the same name. It is therefore said to be heterogeneous compound data type. The components of a record are called fields or members, and each field has an identifier and a data type. The latent records or the latent fields always form a record, and the latent records form files. Generally, a record can be seen to be a collection of data items which are logically compiled into a single unit. The following is an example of a record. My record that I want to use to demonstrate this example is student. This student, or the record for the student, is composed of several fields. One is first name, the second one is last name, then we have age, and we have average score. One of the students is James Kimathi. Age is 25, and the score is 76.50. In this case, the record name is student. And my dear students and the rest of the learners, it is important to know the difference between records or structs and arrays. In array, I say that an array is a data structure which is composed of items of the same type. If it is numbers, it is numbers. If it is text, it is text. But a record or a struct data type is composed of various types of data, and therefore its elements are composed of various types. Like as you can see, first name and last name, that is text, or what we call strings. Age is an integer, it's a whole number, but average score is a number with a decimal point. It is what I call real, or what we call floats. And therefore, this record or this data structure is composed of elements of various types. The record in this case is called student. Its fields are first name, last name, age, and average score. The field values are James, Kimathi, 25, and 76.50 respectively. So the above is a record called student that has 4 fields which contains data of the following types: string, or what we call array of car, an array of car or string, integer, and float respectively. So as it can be seen, just as I have said, the struct called student is composed of 4 members, out of which 2 members are of type string, One is of type integer and one is of type float. Therefore, records or structs are derived data types because they are constructed using objects of other types. The main difference between arrays and records are, number one, both arrays and records are structured data types made up of many elements, but the elements in an array are of the same type, while those of a record need not be of the same type. Secondly, the components of a record cannot be accessed directly using computable indices, as in the case of array elements. So, how do we define records or structs in programming language? The type of each component or field is specified within the record definition. The record definition creates a new data type. The name given to the record becomes the new data type, and it's thus used to refer to the entire record, that is, its physical structure. There is no storage aside when a structure definition is made. The members of a record cannot be initialized inside the definition. The syntax for defining a record in Pascal is as follows. Type record name equals to record, followed by the member. We have member 1, data type, member 2, and its data type, etc., up to the last member and its data type. And then we have end with a semicolon. So that's how we define a record data type in Pascal. For example, the previous record called student can be defined as follows. Type student equals to record, then first name of type string, maximum of 6 characters, or size 6. Last name, maximum of 8 characters and of type string. Age, type integer. Average score, type real. And then we have end. So that's how we define a data structure that we call record in Pascal. The syntax for defining struct in C, or the way we define struct in C for this same structure or record is as follows. The keyword struct introduces the structure definition, while the identifier structure or structure age is the structure name. The student structure above can therefore be coded as follows in C. My dear students and the rest of the learners, note that in Pascal, we use the reserved word type, but in C, we use struct. So we want to define our struct or our record, which is student. So in C, we call it struct student. And then first name, we declare the first member, which is first name of type char, that is array of characters, and its maximum of 6 characters. Then we have array of char for last name, which is supposed to not exceed 8 characters. Then int age, float average score, and then we have that right brace with a semicolon. Even though the fields of a record are declared just like the variables with a type and a name, they are not variables, but the type just informs the compiler the type of data that will be held by the new data type. So the members of a structure are its properties. The purpose of a record or struct definition is just to create a new data type that is used to declare variables. So how do we declare a record or a struct? After having defined the record or the struct, then we have to move on and declare the record or the struct. A record or struct is said to have been declared when its variable is declared. Variables of the new data type are declared just like other variables. A structure variable is called an instance, and an instance of a struct is called an object. You can declare several variables of the same struct or record type, just like other variable types, by separating them with the commas. A memory location is only reserved to hold a record when an object of that record is declared. To be able to access the members of a record, you must pass through the object of that record or struct. The syntax for declaring a variable or object of a record in Pascal is as follows. We have var, object name, then record name. My dear students and the rest of the learners, kindly note, record name is the name for our record. So whatever we are declaring, whatever variable we are declaring is simply of the type record or type struct. For example, we can declare a variable called student details, which is of type student. So in this case, student is acting or serving as our new data type. But remember that records are user-defined data types. While the syntax in C is as follows. It is struct record name followed by object name. For example, struct student details. Remember, student details is the variable, while student is the data type. And we use the reserved word struct. How do we access structure members? A component of a record is referred to through the record's variable name. Its syntax is as follows. Record variable name dot member name. For example, student details dot first name. So you access the member called first name by passing through the name or by passing through the variable that is supposed to be used to manipulate those members. So in this case, ours is student details. So it's student details dot first name. So the structure member operator dot, or what we call a structure member operator, which usually is called period in other areas, accesses a structure member via the structure variable name. Members cannot be accessed directly like ordinary variables because they themselves are not variables. So how do we initialize records or structs? These are initialized just like it's done for arrays, that is using initialized lists or using assignment statements. The syntax is record name dot field name equals to value. So how do we read this statement? This statement reads as follows. Assign the content of memory location record value to the field name for the record name. For example, to initialize a structure called the student in C, it can be done either as student details equals to. So in this case, we are assigning or we are allocating or assigning the following values into the various members for our record. So we are assigning James, then Kimathi, 25 and 76.50 into the record through student details. So we are assigning these elements to the variable called student details. Remember, each of these elements represent a certain type. They are ordered in a certain order. For example, James's first name, Kimathe's second name, 25 is age, 76.50 is the average score. Or we can do it as follows. Individual elements can be initialized as follows in C. Assign James into student details.first name. That is, assign the string James into first name member of the record. Assign Kimathi into last name member of the record. Assign 25 to age, which is a member of the record. Assign 76.50 to average score, which is a member of the record. So you can see we have the object dot the member equals to on assignment operator, and then the value. But a structure in C should never have an element of float type. So floats should always be rounded and stored as integers in C. In Pascal, to initialize each element, just change the assignment operator from the one used in C. For example, to assign James to first name, it's done as follows. It's James assignment operator. So the difference between C and Pascal is simply the assignment operator. So we assign in the same way we assign in C. In Pascal, if we wish to access a particular record and perform operations on several or all of its fields, instead of preceding each reference with the name of the record, for example, student details.age, student details.first name, student details.last name, etc. We can omit the record name from the field references by using a with statement, because as you can see, we are repeating student details.age, student details.first name, student details.last name. So we can avoid that repetition of the record name by using with. The syntax for with is as follows. With record name, do statement 1, statement 2, etc. For example, to initialize the fields in the student record above, it can be done as follows. With the student details do, begin. Assign James to first name. Remember, first name is a member of the record. Assign Kimathi to last name. Assign 25 to age. Assign 76.50 to average score. And then end. So this is a simplified way of assigning various values to the various members of the record by using or the record name once within with do. With the student details do, begin. I have said you assign each member there is a respective value. So the with statement enables the field identifiers of the specified record variable be used as ordinary variables. Inputting data to and outputting data from a record. How do we do it? The syntax for inputting and outputting data to or from a structure is just similar to the other variables, except that we precede the member with a variable name. The following is a sample program in Pascal that implements a record data type that we have called the student. So our program is students. Then we declare uses. We also define a record. So type student equals to record, first name, type string, then characters, last name, string, not exceeding 10. Then age, type integer, average score type real, end. So we begin, we clear the screen, we display that statement, enter the student details. That is student's first name. we read the value that will be entered by the user, and that value will be entered into the first name member through the object student details. So that entry will be captured and be stored in memory location called the first name and the record. Then enter the student's last name. We read what is entered, and it is assigned to student details dot last name. So it is assigned to last name member of the record. Enter the student age. The value entered is picked and stored in memory location called the age, which is a member of the student details, or which is a member of the record. Enter the student's average score. Within the average score, within the value, and that value is stored in the record under the average score part. We then clear the screen. We then output the values of the record by displaying this statement. This student details are. That is the formatting of the text. There's a right line for one blank line. And then we have the following headings. First name, space 15 characters or spaces. Last name, 15 spaces. Age, 15 spaces. Average score, 20 spaces. That is for formatting purposes. And then we use with. So with the student details do. Remember, student details is the variable or the object name of type record. So with the student details do begin. So write out first name or the content of first name, formatted 15 spaces. Content of last name, formatted 15 spaces. Content of age, formatted 15 spaces. Average score, formatted 15 spaces, part 2, being reserved for the fractional part. And then we write out one statement of blank line and we add. And then we pause on the screen, reading nothing to give the user opportunity to see the output. That is the end. What about in C? So the following is a sample program in C that implements a struct data type that we have called student. So we have a precursor directive. Up to now, we know what it means. Then we define the record or the structure, struct. So struct student, we have that in place, the left in place. Then we initialize or we declare or we define the various members. The first member is first name, size 10 of character type. Last name, array of characters, not exceeding 10 of type char. Then age, int. Then average score of type integer. And then we end our definition. So we move on to main function. And we now declare an object that will be used to manipulate the content of the record. So we define a variable called student details of type student. So struct student, student details. Then we display the message enter the student's first name within the content or the name that will be entered by the user. That content will be stored under the first name member of the record through student details. Enter the student last name. Whatever will be entered will be picked and stored in the memory location called last name, which is a member of student details or a member of the record. Then enter age. With the age, we prompt for average score. We read average score. Then we output the values entered. We display those as headings and formatted those spaces. So student name, age, average score. So this is going to display or write out the student name, the age, average score. So we write out. The other ones, it will read as follows. The output will read as follows. Student name. We pick what is in first name. That is student details dot first name. We display. Then student details.last name. The content there is rent and placed next. So student name, so and so. Age, we pick the content memory location called student details.age. We display it on the screen. Then average score, we pick the content of the memory location called student details.average, and we display it on the screen. And then we can control the operating system and end the program. Let's now look at array of records, or what we call arrays of instances. Array of instances is similar to the arrays that we covered before in terms of the way the struct members or instances are manipulated. It is therefore possible to declare an array in which the elements are records. Arrays of instances are implemented through declaration statement of a record by declaring an array of the records variable. The syntax for declaring array of instances is as follows in Pascal. We have var object name, then array. We write out or we indicate the size of our records, the number of record type. For example, var student details, array 1 to 7 of student. My dear students and the rest of the learners, kindly note, there is no difference between the way we do it in records or structs from the way we discussed before. The only difference is the data type, that now we are using a new data type, which is a record or a struct. Otherwise, the way we declare, the way we pass, and everything is the same, even for records or structs. While it's declared as follows in C, it is struct, record type, object name, then number of records. For example, struct, student details 7. Remember, the student is the name of the structure. It is our new data type. It is our new data type. While student details is the variable. So 7 indicates that it is an array of records or array of structs. Then we can access and manipulate the members of the various instances, just like discussed previously, but then we include the instance subscript in order to identify various instances of the program. The syntax for accessing a member therefore becomes instance name, then index or subscript dot member name. For example, student details 1 dot first name. So we assign. So we can read this statement as follows. Assign James, or James is assigned to the memory location of the array of record called first name, the array of record, the first member being first name. So assign James to the first name member in the array, but at position 1 or subscript 1, or assign James. So the difference here between C and Pascal, my dear students, is simply the assignment operator. Otherwise, it's just the same. If or in C, you can initialize arrays of instances as follows. Like here, we can assign, or we can initialize the various members of the record code or of the structure called student through the array of records, that is through the variable student details as follows. So we are assigning Janet, the first member, Aremi, next member, 15 next member, and 84.63, the next member in the first record. Then the second record, because this is an array of records, so it is 3 records. So that means we also have to do the same. We assign James, the first member, Jogona, second member, 25, next member, 76.54, next member. Then Anne, for the land record, Anne, the first member of land record, Kamau, second member, 32, next member, 90.00, the other member. And that's all. That's how we initialize all the members of the array of records or array of structs. A control structure that performs iteration is always used to control the number of records being manipulated using a for loop. For example, the following programs manipulate the following student records in C and Pascal. So our record or our structure is called performance. It has first name, last name, age, cut, exam, and total. First record is Anne Karimi, age 22, cut 16, exam 54. Second record is Silas Jogona, 18, 30, 70. That record is Mary Atieno, 35, 21, 60. So those are the three records. But then we are going to compute total. So the following is a Pascal program implementing the students' records for performance as indicated. So program is results, we declare uses, then we define the record. So it is type performance equals to record. First member is first name. Maximum size is a string, or its maximum size is a string or an array of car whose size should not exceed 6. Then last name is a string, or what we can call in C, array of characters not exceeding 8. Then age of type integer, cut integer, exam integer, total integer, and that's the edge. So this structure or this record has 7 records. It has 7 members. It has 7 members. This record has 7 members, 2 of type string and 4. In fact, it has 6 members, not 7. It has 6 members. First name, last name, both of them of type string. Then age, cut, exam, and integer, being of type integer. So it has 6 members, 2 of type string and 4 of type integer. Then we declare a variable or an object that we are going to use to manipulate the members of this record. And this is student details, but it is an array of 1 to 3 or performance. So it is an array of 3 records. An array, it is going to be used to manipulate members for 3 records. So it's an array of records. Then we have integer or I, variable I of type integer. And then begin with the other screen. Display this statement, enter the following student details, and then we use for loop for the process of reading. We initialize I to 1, to 3. So we check if the value of I is less than 3. If yes, with the student details, 1, do, begin, write out first name within the first name, the value or the name, the content entered. The value entered will be stored in first name member for the first student record. Last name, the last name will be read and be kept in or be stored in the member for the first record. We read also age, the same will happen, cut, then exam score. So the values would have been entered for the first record. Then we count, we pick what is in the memory location equal to exam, that is student details 1.exam plus student details 1.cut. We add the two and we store in a variable called total, or a member of the record called total. And then we finalize with that student, and then we increment the counter by 1. So I becomes 2. 2 is less than 3. So we repeat again. with the student details to do. So first name, so the value of first name, the value will be picked and be stored in member for the second record, or for this for record 2, student 2. Last name, the value will be read and be stored in last name for student details 2, that is record 2. That will happen, and all the details for the second student will be captured. Then the content of in the memory location for the exam will be added to what is in the card, and that will be stored in total. And that will be the end of the second record. And then counter will be incremented again from 1 or from 2 to 3. And then the same will happen for the third record. And once that is done, then I will be incremented. So 3 will be incremented with 1. It becomes 4. So it will have exceeded the maximum value, which is 3, and therefore the for loop will terminate. So let's now display the student details or students' results. So we clear the screen, we write out this statement or heading, students' performance, formatting the spaces. Then we underline, we write out a blank line. Then we have the following headings: number, first name, last name, age, part, exam, and total, formatted or spaced as follows. Then we have our for loop. For, we initialize I to 1, to 3, do, or we initialize value of I 1, then check if the value of 1 is less than 3. Yes. So we do the following. With the student details 1, do. So we begin. We write out first name or I, that is the number, first name, last name, age, cut, exam, and total, formatted as follows. So this statement will pick the content in the various members for first name, last name, age, cut, exam, and total. For the first record, write out a blank line, and then increment the value of counter by 1. So it becomes, I becomes 2. 2 is less than 3. So with student details 2, do. So we read first name, last name, age, cut, exam, and total for the second record or second student. And then without a blank line, then we increment again the value of I. So 2 plus 1 is 3. So we check, or we say, with the student details 3, do. We read the members, the content of members, first name, last name, age, cut, exam, and total for the third student. And then we increment again with 1. So I becomes 4. So 4 is 4 less than 3. No. So we terminate the loop. Iteration stops. We pause for the user to see the results, and we end the program. This is how we do the same in C. So we have a pre-processing directive. We define a constant stored in 8.3. Then we define structure, struct data type called performance. So we define it, or we define it as struct performance with the following members. First name is array of characters. Then last name, array of 8 characters. Then age, cut, exam, and total of type integer. So those are the members that will be that new data type. And then we move to the main function. We define, or we declare an object of type performance. And this is an array. This is an array of records. And therefore, it is struct performance, student details, maximum size 3. And we call that an instance. Then we declare also another variable called I, which we are going to use as our counter. Then, just as we have done for Pascal, we do the same for C. We display the message, enter the student details. Then We initialize counter to 0. We check if the value of counter is less than num. Num is 3, so it's 1. 0 less than 3, yes. So we display that statement. The user enters first name. That value is stored in student details subscript 0. Then last name. So the user enters the value of last name. That value is picked and stored in the member last name, but student details 0. And the same will happen for age, for cat, for exam. And then we add the total. Pick what is in student details 1 dot exam in exam, and to what is in student details 1 dot cat. So add cat and the exam. The total, assign it into the member location called student details 1 dot total. Then once we encounter this brace, we implement the counter with 1. So 0 plus 1 becomes 1. That's what I plus plus means. So we check, is the new value of I less than num? So is 1 less than num? Yes, so we do the same again for the second record. Wherever I is, it is 1. Student details 1 dot first name, student details 1 dot last name, student details 1 dot age, student details 1 dot cat. And we also do the same for exam, and we add. Then we implement counter by 1. So 1 plus 1 is 2. So is 2 less than 3? Yes. So we do the same for the third record. Student details 2 dot first name dot last name dot age dot cat dot exam. And we add the same. Student details 2 dot cat plus student details 2 dot exam. We assign it in student details 2 dot total. Then we increment the counter. So 2 plus 1 is 3. So is 3 less than 3? Is 3 less than num? No. So we exit. We don't do any of these operations. And that's all. So we then display the student's results. So we write out this heading, student performance, formatted left spaces. We also print out an underline. And then we display this statement. Number, NO, first name, last name, age, cat, exam, and total. In other words, the content of each of the members in our array of records will be displayed as follows and formatted as follows. So first name will be formatted 15 spaces. Last name, 16 spaces. Age, 80 spaces. Cat, 80 spaces. Exam, 80 spaces. Total, 80 spaces. In other words, those headings will be formatted or spaced as specified in this statement. And then from there, we use for loop to do the reading and writing on the screen. We initialize 0, I to 0, and then we check if the value of I is less than num. If yes, we do the following. We print out the first value of I, and then followed by the content of student details 0 dot first name, student details 0 dot last name, student details 0 dot age, etc. up the last one, and then we write out a blank line. Then we implement the value of counter with 1, and I becomes 1. Is 1 less than 3? Yes. So we repeat. We repeat by writing out the content of student details 1 dot first name, student details 1 dot last name, student details 1 dot age, etc. Then we write out a blank line. We implement the value of counter with 1, so it becomes 2. So is 2 less than 3? Yes. So we do the same. We write out details for the that record or that student. And once that is done, that becomes the end of writing out the student results. So let's look now at how we pass structs to functions. Structures may be passed to functions by passing individual structure members, by passing an entire structure, or by passing a pointer to the structure. When structures or individual structure members are passed to a function, they are passed by value. Therefore, the member of a caller's structure cannot be modified by the other function or by the called function. Arrays of structures, like all other arrays, are automatically passed by reference. To pass an array by value using a structure, you create a structure with the array as a member. So, because structs are passed by value, so the array is passed by value. In the previous program, the first and the last names were array members. You can pass an instance of a struct as a parameter to a function. Here, we use the instance name as an actual parameter, just like in passing variables. The formal parameter is declared just like in variables, but now we declare it as an instance. The following is a sample C program implementing passing of a struct to a function. We have our preprocessor directive for standard input output and a file called stdio.h. Then we define our struct as struct performance with the following members: first name, array of car, size 10. Then we have prog and os as int member functions or int members. We have total as a member of type int, and we then declare an object to manipulate the members of this struct. And we also need to define various functions for use. So this is a prototype, or it is a prototype for a function called input details. This prototype for the function, void function called input details, is receiving one parameter, and this parameter is an array of structs of type performance. And it is students, or I repeat, this is function prototype for the function called void input details. In other words, it is like declaration of the void function called input details that is having one parameter. And this parameter is an array of struct. It is an array of struct, and the struct is performance, while the object for manipulating that array is students. The next is a function declaration by the name compute total, which is also receiving one parameter, which is an array of structs by the name performance. We also have the value prototype or function declaration, which is a void function by the name output results. And it is also receiving one parameter, which is the array of records, or the array of structs. Then we move to the main function, which is void main. And we have our declaration for the struct. And here we are declaring students of type performance, and this is an array of struct. So we call it array of instances. Then we also have a call statement, that invokes the function called input details, and it sends to it the students which is an array of structs or instances. Next is a function call by the name compute total. It is invoking the function called compute total and setting it the array of structs. That is, array of structs by the name students. In other words, it is passing compute total the array of the structs. We also have the other statement which invokes the function called output results and passing to it the array of structs. And that's all with the main function. So those are the functions, or those are the call statements that will be invoked to execute the tasks being performed by the various functions. That is the input details function, compute total function, and output results function. Let's now go to the various definitions for the functions that have already been prototyped. So the first one is input details. It is receiving an array of structs, and it has a local variable called int I. Then it displays a statement. Enter the 3 students' names and their scores in the programming and operating system. Then we have the for loop for reading the various values for each student. It is initialized, or I is being initialized to 0. Then we check when the value of I is less than 3. Yes. Therefore, we display the message student and the number of the student is student 1. Then, and the first name, whatever is entered as the first name is picked and stored in memory location called students 0.first name. Then for the score in the programming, the same. The value is read and stored in memory location called student 0.prog. And then the score in operating system, the value entered is stored in memory location called students 0.os. Then once this places an counter, the loop repeats. So the counter is incremented by 1. So 0 plus 1 becomes 1. Is 1 less than 3? Yes. So we do the same. We enter first name for student 1.first name. We enter the score in programming in students 1.prog. And we enter the one for operating system in students 1.os. And then we increment the counter again. So 1 plus 1 is 2. Is 2 less than 3? Yes. So we do the same. We capture the details or values for the random student, and then we increment the value of counter by 1, so it becomes 3. Is 3 less than 3? No. So we exit that loop and we exit that function. By this time, we shall have entered all the student details as required, and therefore we shall have entered details for 3 students, that is, these structs. Then we compute total marks for each student with the function called compute total, receiving the various elements or the values in the array of structs that we have already entered. And therefore, it has one local variable, which is the counter, and the for loop is used for the purposes of doing the iteration. So we move to the first statement here, which is we pick the value in memory location called students 0.os. We add to the content of memory location called students 0.prog. The total we assign it in students 0.total. And then we increment the counter by 1. So 0 plus 1 is 1. Is 1 less than 3? Yes. So we pick the value in the memory location called students 1.org or OS. We add to the content of memory location called students 1.prog. We assign it in memory location called students 1.total. And then we increment the counter again, the same. So this will continue until we have calculated the total for the 3 students. And then once the value of I is no longer less than 3, we terminate the loop. Then we display the data in our structure. So through the function called output results, it is also having one parameter, which is array of structs. Therefore, it displays the following message that the following are the results for the students. And it displays the number of the student name, the score in programming, score in operating system, and the score in total or his or her total marks. And therefore, we use the for loop for the purposes of displaying or outputting. When the value of I is 1, we display number 1. And then, or when it is 0, we display 0. And then we display the content in the memory location called student0.firstName, formatted 14 spaces, followed by the score stored in student0.log, formatted by 15 spaces. Then the value in students dot, that is 0.os, we display formatted 15 spaces. And then we display the student 0.total, whatever is there, we display it for that student's total. Then we drop one line, or we print out one line. Then we increment the value of I with 1. So is 1 less than 3? Yes. So we display the student's the second student's first name, second student's score in programming, second student's score in OS, second student's score or total score, and then we drop one line, increment count again, and then we do the same for the band students. And once that is all, we shall have displayed all the results or all the scores for the students. That is the student number, student name, score in programming, score in operating system, and total. And with that, my dear students and the rest of the learners, we have come to the end of section 7. Continue section 8 of 13 in this topic so that you can learn more about the other data structures that we use in C and Pascal programming. Congratulations for learning section 7 of 13 in the topic data structures. You can also access sections 1 to 3 to 13 of this topic, other topics in the computer structure and programming unit, as well as other computer or ICT videos by clicking or tapping on EMELISWAP ICT YouTube channel below this video. You can also visit EMELISWAP Life Skills YouTube channel for free life skills, motivational, and inspirational resources.